What's going on, guys? In this video we are going to see an example on shortcut method for reduction of order, and in order to apply the shortcut method we have to have the differential equation in this pattern: y double prime plus a function of x y prime and another function of x y is equal to 0. And if you notice this first term, the coefficient of the first term should be 1. That's the main thing. Now if you look at our differential equation, we have x square y double prime minus 3xy prime plus 4y is equal to 0. So we have to turn this first term into 1. The coefficient should be 1. In order to get the first term 1, we can divide everything by x square, and if we divide, this is going to become y double prime, and this is going to become 3xy prime divided by x square plus 4y divided by x square is equal to 0. Now after we turn in this one, we can apply the shortcut method. This is our shortcut method. Now in order to apply shortcut method, first we have to find a p of x value. P of x value is basically the value that multiplies this y prime, and in our case, but before we do that, let's simplify this one. We can simplify this one furthermore, like y double prime minus 3 over x y prime plus 4 over x square y is equal to 0. And here whatever the value that's multiplying this p of x is, y prime is p of x. So in our case that's negative 3 over x. So p of x right here is negative 3 over x. And after we find out p of x value, we can directly go ahead and plug it in this shortcut formula. So let's say y of x is equal to, I write it as y of x because this is going to be our general solution. After we find this one, that's going to be our general solution, and I'm going to write second solution as y2x. So that's why I keep this one as y of x, general solution. So y1x in our case, that's given this given solution, that is x square. So I'll directly put that one right here. I'm following this equation, y1x and times integral of e power negative p of x. And here we already have a negative, and in the equation we have negative. Negative, negative, that's going to turn this one into positive. So we just have e power integral p of x, that's going to be 3 over x dx, and in the denominator we have y1 square x. Y1 square, y1 is x square, and if we square this one, that's going to be x power 4, and then here we are going to have a dx. Now let's simplify. This is going to be x square, and this is going to be 3 ln of x, e power 3 ln of x. If we integrate this one, 3 ln of x, and also there's going to be a constant plus c divided by x power 4 dx, and we can move this 3 to the power, right? If we do that, we can get rid of this, like e and ln cancels each other, right? So let's go for the next step. X square integral e power ln of x cube, and when the powers add, it means this is multiplying. We can multiply this one by e power c. Okay, now this is multiplying, and in the denominator we have x power 4 dx. Now let's continue this one right here. Okay, so here we have e and ln cancels each other, so we are going to have x square integral e and ln cancels each other, we are going to have x cube, and then e power constant, instead of that one we can just write c2. Okay, that's another constant. So let's say e power constant is equal to c2, and that's this one. And then in the denominator we have x power 4 dx, and now we can simplify this one furthermore, like x square integration 1 over x c2 dx, and c2 is a constant, and if we integrate this one, that's going to be ln of x. So x square times ln of c2 ln of x, because c2 is a constant, we can multiply that one in front, c2 ln of x, and we are going to have another constant, let's say that is c1. Now we have to multiply everything, and this is going to become c2 x square ln of x, c2 x square ln of x plus c1 x square, and this is going to be our general solution for this differential equation. But in the question they have asked general solution and the second solution, so this is our general solution, And if you look at this one, the given solution is when we have c2 is equal to 0 and c1 is equal to 1. That gives us the given solution, y1x is equal to x square, right? And if we make c1 equal to 0 and c2 is equal to 1, that's going to be the second solution. So here, if we make c1 equal to 0, this whole thing will be eliminated. And if we make c2 is equal to 1, this is going to be x square ln of x, and this is going to be the second solution for this differential equation. I hope this helps. Thanks for watching.